So today we're going to discuss a fundamental topic, which is unit vectors. We can define a unit vector as any vector with a magnitude equal to 1. So basically, a unit vector is used to define a direction in space. So in the 2D space, like the one shown below with the x and y axis, there are typically two unit vectors that you see. I, which points in the x-axis, and j, which points in the y-axis. Now, there's a couple important things to note. The first thing to note is with the notation of the hat, that indicates that it's a unit vector. And I just want you guys to remember that these vectors have magnitude 1. That's really important. We can show a use for these unit vectors graphically by using this random vector A. To express A in terms of unit vectors, we need to break it down into components like we did in the previous videos. And once we break it down into its AX and AY components, we just multiply it by the unit vector. And that's what's shown on the right. Now, the more important way to express this is actually analytically. So below, we can see that the A vector is equal to AXI plus AYJ. And so that is just an analytic representation of the graph on the right. It's also important to remember that AX and AY, those are the vector quantities, and then I and J indicate the vector direction. So this equation and the purple vectors in the diagram are expressing the same thing. So this idea of unit vectors makes vector addition a lot easier. So as you can see below, we can take two vectors A and B, and if we represent C as equal to A plus B, all we have to do is add the amplitudes, and we keep the unit vectors the same. We just add the correct amplitudes together, so the AX plus BX and the AY plus BY, and we get the resultant C vector.